Welcome everyone to the talk Mystikcon 2021, and today's topic of the talk is blockchain and smart contract security design and code auditing. My name is Mukhtar, and first of all, I would like to say thank you to the organizer of this Mystikcon and for community. So yeah, this talk is more on the security and the difference of the smart contract, which says the traditional software development. So I just wonder how many of you have knowledge in smart contract and how you are familiar with the Solidity code syntax. So yeah, this is just to give the idea about the blockchain and smart contract, and also we will discuss about some vulnerable code sample, and we will see some specific vulnerability in smart contract, and also we will do some hands-on code auditing. So who am I? So I am Mukhtar Serikbayev. I am offensive security consultant at HelpAG UAE Dubai, and mostly I'm handling application layer security, including mobile, web, and the source code audit. So this is my second talk at Mystikcon, so I'm really glad to be here. So what is a blockchain? So blockchain is actually, in simple words, it's just electronic database which can help to relevant stakeholders to store their record or access to their record. And smart contract is just a programming code which is located in the blockchain, which helps to automate and trigger some actions when conditions are met. So in order to properly understand the blockchain, so you should be familiar with these principles. This is core principles of blockchain. It's one of the principles is the security, trustlessness, distributed ledger, decentralization, group consensus, and immutability. So smart contract is a new paradigm of software development. What I mean is that that's interesting. Like if you don't code before, so it will be maybe easier than if you code before, because let's say in a simple application, like if you want to get some weather for the Dubai, and you just fetch API URL from, for example, in Python language, it will be like 2-line code. So you just import some library and you just fetch some URL and you will get the information. But how it will look like in Solidity? So in Solidity, it will look like similar, something like this. Do you think this will work? So it will not work because of the difference of the Solidity and the blockchain. First of all, so this is the screenshot of the 2 days maybe. So in the world is around now is around 13,000 nodes, which is the mining, or which is doing some transactions over the world. So blockchain is, first of all, it's so all the nodes are executing in different time zones. For example, if you want to get some stock price for the Apple, you will get it, but it will get maybe some different information because of the different time zone. And also these nodes are closed systems. You don't have access to internet. They are working on internet, but they don't have access to internet. And also it's deterministic, so there is no random information. And so for example, so it's not the final stage. So there should be some consensus to be the valid transaction. For example, again, that back to the example of Apple stock, it will not be the final price. There is some solution like oracles, which is supposed to work for external data, but this is not scope of this talk. So again, so we will see in traditional software development, for example, to create some password protected vault. You just store the password of the password in the database, and when password is matched, you just unlock the vault. So let's say in Solidity it will be something like this. So like function vault, you just put the password, so it will store in variable password, and when you call the unlock function, it will unlock. So again, this will not work because of difference of the blockchain and Solidity. So again, your password will be in public, so everyone will see your password. And this cannot be this variable cannot be stored as a secret because of the public. Even if you say the private, so this is a common mistake in Solidity. So even if you put private, so all miners will see your password in transaction. So again, if it's in best practice of software development, like traditional software development, you save the hash of the passwords, not the actual password in your database. So in Solidity, you have the same hash function like cache check. So it's like similar to the SHA-3, and the line which will change here is it will be so it's the same like function vault. You store, instead of storing the password, you store the hash of the password. So when the function unlock, you just put the right password. It will check the hash of the password, and if it's matched, it will unlock. Again, this is the vulnerable code. Maybe in traditional software development it might work, but in Solidity, in blockchain, it is the vulnerable code. So let's say let's do more exciting. So let's pay 100 ether instead of just like locking, unlocking. So let's pay 100 ether if someone finds the password. So again, as I told, it will not work in Solidity in Ethereum network because of. So I will explain in the next slides. So enter the Ethereum. So Ethereum network is a permissionless public blockchain, and it's totally different from the cloud and so it's totally different from the cloud or online services. So what I mean by that, so it's all the transactions, they have stages. So it's not the final one. So all the transactions is, first of all, it will create in locally in the miners, locally in nodes. After it will broadcast to the decentralized network. So in this case, we are talking about an Ethereum network. So everyone will do the same. So everyone is putting in their local nodes after they're appending to the blockchain. And this recent transactions is which is locally mined, so it will store in the mempool. So again, so for example, if Alice want to send to Bob, so there should be some actions. For example, before sending to the, it's not like in the APIs calls or server calls. It will not be like final call, for example. So there is some stages which needs to be done. So another concept I would like to talk is Ethereum has incentive model. So blocks are scarce and the block size is limited. It's because of the competition, storage, network, and other reasons. So there is a market for the who can join to these transactions. So in order to solve this computation, storage, and network, Ethereum introduced the concept of gas. So which is similar to mining Bitcoin fee, but it's a little bit different. So if you want to define, it is a unit payment of the computation. So basically, you are paying how much you want to compute. So this can be just sending one transaction, or it can be uh, some difficult calculation. So based on that, you just put the gas price. So it's similar to the gas fuel price. If you want to drive from A point to B point, you just pay some amount of money. So here in Ethereum, it's in Ether. It's a gas price. Also, there is some gas limit, which is a maximum amount willing to pay. Also, you should consider, like, while you developing your smart contract, there is a block gas limit, so which every block can have the maximum gas limit. That means that you cannot do any complicated computation in one transaction. So there is a limit to do that. How much complicated your smart contract. So there is also another thing. So anyone can change the transaction priority by paying higher gas. So just because of miners behave on economic incentives. If you pay a lot of money to miners, they would mine your transaction first. So this concept can handy if you have if you have something like real, your smart contract needs to be more optimized to the gas. So if you, for example, if you have some normal smart contract which is spending a lot of gas, so there will be some sending a lot of money just to send one transaction just to compute the one transaction. So another concept which I want to talk is the front running. So this front running is an old concept which is on traditional stock market. It was from 70s. So where someone is know about upcoming orders, so they will just go and buy, and after the price changes, they will sell in higher price. So now it's illegal, but in Ethereum network, so all the miners are in this privileged order. So they will say the all transaction in mempool. So they can, for example, whoever is pay higher price or higher gas price, they will mine first. So in order to visualize it, so this is a current transaction. This in I will show you. So it's in yellow. It's a mempool which is waiting for the miners to mine it and append to the blockchain. So in green, it's already blocks which is already mined, and in yellow, which is this is a mempool which is waiting for the miners to mine this transaction. So in order to visualize in blockchain, so all the miners, they can front run transactions, they can, for example, they can see the from mempool the transaction and mine it first. So getting back to this application. So again, someone can front run and see they can do the transaction for unlock. They will see the they will see the they will see the password and they will just call the first unlock function. So which is and even if you put the right password, so there will be already there will be 100 Ether is gone to another person because of the front running. So this was a simple. So anyone's if anyone front run unlock function by sending the higher gas price, you will get 100 Ether. So in order to solve this issue, Ethereum came with a commitment scheme or a commit review. So so one of the solutions is commitment scheme is which means you have to break down your request into two transactions. So first, you send the your commitment with the time, and second, you just wait for a few blocks, to send your reveal scheme, the reveal transaction. So it can be prevented from the front running, blind auction, or gambling games, a lot of other things. So code auditing. So in smart contract, so have you guys done any code auditing before? So there are security tools in traditional software development. There are way more, a lot of security tools which can be handy on code auditing. But in smart contracts, there are few, and they're just helping to find the common misuse patterns, or it will just show you the idea about your smart contract. But you still need to do manual reviews, and after a lot of hacks for good or bad, it's becoming industrial standard to hire external code auditors. So this means there are going to be a lot of jobs coming on this field, but it requires a lot of expertise. So, so for hands-on auditing, I wanted to do some real-world application. This is a smart contract Ethereum name services. So basically, it's the same like a DNS server. So it is for Ethereum name service. So like if you for DNS is like human readable names to identify address for your network. For example, if you want to go to google.com, instead of typing your IP address 172, you just type the google.com and DNS server resolve it. So similar to Ethereum network. So instead of typing your wallet address, instead of typing the 0x57, you just type the google.is, and the ENS will resolve this, and it will send the right address. So in order to buy these domains, it was a on-chain transaction. We have to send transaction to smart contract of ENS controller to purchase domain and use it to be blind auction. Like you send some money to buy some domain. After 2 days, you just reveal it and you will buy it. So, but from 4th of July 2019, they switch it to instant domains. It's like similar to the similar model to current domain. Like you rent, it's rent based. So it's again, this smart contract, it's called funds in the smart contract. And also they come with some commit review scheme to prevent front running. Like for example, before for example in 2000s, there were some same like happening in the traditional like DNS domain purchase. Like someone was buying this domain and to resell it to higher price. So so I will do the code auditing in the Visual Studio. There is some very handy extensions for Visual Studio. So you can download this code from this link and open the Ethereum register controller. So basically, is all the smart contracts in so it's the structure of smart contract. You know, whatever in this contracts is a smart contract, and there is also some travel packages which you can see in test. So you can create your like local network to to implement this smart contract. So basically, it depends on the auditor, like how they start the code auditing. Maybe someone start from top to down to manual review, but I personally start from the access controls or the or modifiers like only owner, is owner, and address transfer. So it will give me idea how is the quality of the code. Also, there is some handy extensions, as I told you. For example, inheritance. So it will inherit the no, it's not working. Or the graph view. I don't know what's wrong here, but basically you can also install the extension Solidity, and you can graph this. It will give you a graphical view of this smart contract. So where is, for example, as I told you, these modifiers is very critical, and we just show you here in smart contract. So for example, in withdraw function, so it's the only owner. That means whoever the owns this smart contract, only owner can withdraw all the funds. So this is just this is a security concern because only owner can withdraw the fund. So this should be in the security report. So as I told you, in to prevent the front running in Ethereum networks service, they implement a commit review process. To register the name, the user must first of all generate commitment hash using the name and the secret value. Secret value can be generated automatically or it can be used from the user. then submit to the controller and wait for 1 minute or not longer than 24 hours, and submit the registration request for the name along with the user. So this is as per their documentation. This was to prevent the front running. It was implemented commit reveals process. So I will show you in code. So here is a make commitment. So it will take the two variables, name and secret, and it's pure public. That means this transaction will not go to the blockchain. So miners will not see the secret. And there is a commit scheme, which is which will show the if it's committed before or not. If it's committed, so it will just go to return. Also, there is a register function, which is which will take the name, owner of the who wants to register, and duration and secret. So it will change. It will check the minimum commitment. So it will check the for which amount of time they want to register. Uh, so what's wrong here? So here, so this was a commit review scheme, but do you think there is something wrong with here? So again, there is a security bug here. So it's there is a this make commitment is vulnerable to the front running because of on register on the make commitments they are not tied into the owner. So because of that, so on someone can front run this call the register with the name of the other name of and they can register with a different owner. So in order to show that it's a bug, you need to come with the attack scenario, because in during the attack scenario you will see the is it actually vulnerable or it's just some mistake happening. So attack scenario. So for example, Alice calls the make commitment with. So she wants to register my domain, and she just put the secret. So she waits for 10 minutes, send it to transaction to my domain, Alice, and secret. And there is duration, but duration is not important. So if observes this transaction in the transaction pool, as I told, as I showed, it's in the mempool. If showed that that this transaction is happening. So in the register function, it's this transaction is going to blockchain. So that time is the secret is revealing and also revealing to my domain. So if submits register with my domain and with her name and the secret with a higher price. So miners will mine this first because of higher price and win the race. So in order to remediate these commitments, so commitments should be committed to owner in addition to the name. So there should be a name also in the commitment transaction. So this code, this code was good, and you cannot find this bug using the automated tools. So you need to understand the smart contract. You need to read the documentation to see like what can happen or goes wrong. So Other smart contract vulnerabilities which I want to tell is it's the same like in traditional. There is a integer overflow or underflow. For example, in blockchain in 2017, there was a bug as a underflow. So developers they they missed this bug because of they didn't check its vulnerability properly, or they didn't scan even this bug. So, for example, there is also specific vulnerabilities regards to smart contract, which is the re-entrancy. So imagine that user calls the first one or the function A, then function B. Uh, but you are not so as a smart contract owner, you are not really control of that. The initial which function will go first. So in the mempool, someone can call this function B first, so they can be reentrancy issue. This was happening in parity smart contract. As I told, also there is another vulnerability specific to the smart contracts upgradability. So there is no if developers they miss this function, for example, to kill or the self-destruct the function. So this smart contract will be in blockchain forever. And also there is no you cannot upgrade your smart contract once it's in the blockchain. It will be stored from now to forever. So there is some solution, for example, in like proxy smart contracts, but again, it's already security concern because users action will be changed without notifying the user. So this is also security concern. And also there is no randomness. It's all the nodes in the blockchain, it's deterministic. So there is no randomness. So once more is a specific vulnerabilities, reentrancy. So the sample of code here above is vulnerable to smart contracts. Line 3 is smart contract fallback. Function may be called, which is call this function again. Since the smart contract has not updated the account balance, which is happening on line 4, the user can end up with withdrawing 2 or more time from the original amount. And this was the DAO hack was happening because of this reentrancy vulnerability. Access control in so in smart contracts commonly give different levels of permission to their owners and the other users. So if the access control code of smart contract is improperly implemented and the malicious user can gain control of the smart contract. The code sample is here is give the ownership permission to the creator of smart contract. But again, there was no so there is no check for like if initial init contract is has already called. So for example, some malicious user can already initiate this init contract and can be claimed as ownership of this contract. So Parity wallet was commonly used this vulnerability to gain this ownership of this Parity wallet. So this is a diagram which is I want to show you. So there is a different layer of layer which attacks will happen, and because of this attack, this vulnerability is happening, and it can cause so external dependency, improper validation. And there are resources that can use it to help the for developing Ethereum solidity and also auditing the solidity. There are some good links, for example, to analyze that smart contract. For example, Mystikcon, Leader, Securify. Also, to create the these smart contracts, you can use the remix and truffle. Uh, Truffle is really good to writing tests, but you need to be familiar with Node.js. You need to be also write the tests for the tests. So it's really, again, it's all the way down. Also, there is I want to show you some best practice, open source best practice websites, which can be really handy to understand the better all the vulnerabilities in Ethereum, in the blockchain. And you can read also public smart contracts. So basically is all the smart contract owners, so all the developers, they want to show their audit report to public. It's not like in traditional reports, they are like it's like secure, or it's like uh, like in traditional like penetration testing, everyone's saying it's like this report should be only for internal, but in smart contract it's more public, because you want to show that this smart contract already passed external auditors. So we fixed this kind of issues. So you can read these public smart contract audit reports, and you see there's some common vulnerabilities which is happening in smart contracts. And also there are a lot of CTFs at the smart contract, so you can be check this out. This is really helpful to better understand like how Ethereum network works, how the this permissionless network is works. So you can hack the smart contracts, you can uh, own this. You can be owner of this smart contracts. You can become owner of the smart contracts. So this is really it will really help for developers to better understand like what can cause this vulnerability, and also for new joiners for the smart contract security. So this is the references which I want to refer, and question and answers. Thanks for one more time for organizers and Melvin.